Welcome to today's class. Today I am going to explain a special type of function called composite function. So far we have learned about a function. Now we are going to learn combination of two or more functions we are going to see. Can't we add or subtract or multiply the functions? Okay, that we are going to see. So this is composite function, or sometimes we call it as a product function also. What is this? So let me see here. As already we know that a function is just like a input output machine. That means it is a machine. So the machine name is it is F. It is F. If you give the input here x, if you give the input x, the output will be f of x. The output will be f of x. Okay, now, right? That up to that we learned here. Now my question is, the output is f of x. Now, further if you give to another machine, see here, whatever may be the, if you manufacture a pen, it will takes a course of step by step process. First they have to prepare this cap, and they have to prepare this pen and ink and a nib, and this again this refill, everything different manufacturing process will come, and ultimately you will get the product. So here also there is a raw material under the machine F. Up to here f of x came. Again this f of x further got processed, and the machine is processed under this f of x is processed under the machine G. What will be the output? So here again f of x is processed in the machine G. So what will be the output? See here, if your element is x under the function f, its image is f of x. Just they are notations, that's all. Similarly, here f of x is an element just like x. Under the machine G, what will be its output? G of f of x. Understand? So, if your element is x, under the process from the machines f and g, the final output is g of f of x. Understand? Right. Further we can go like this process. Again we can go like this. Any number of process we can go. Again if it is go for another machine, if it is go through the another machine, let it call it as a h. The machine is h. If the element is g of f of x, then the output will be h of g of f of x. This will be the output. Like that you can go through the number of mechanisms, number of machines. So given an element x, your output here under the machine f, function f, your output is f of x. Given your element f of x under the machine g, its output is g of f of x. Given the element g of f of x under the machine h, your output is h of g of f of x. Understand this? Okay, right. Now I will explain this process in a set format. Okay, now right. Let us see that set format. Let us see this composite function definition in set form. Let us take two non-empty sets A, B. There are two non-empty sets A and B. Let f is a function from A to B. Okay, now let us take another non-empty set C. Let G is a function from B to C. Already we explained what is a function. Okay, now then, for example, if the element is x under the function f, your image is f of x. Okay. Given an element f of x, your under the function g, its image is g of f of x. Understand? From this, what can you say? Given an element A, there exists its image in C. There exists an image of X which belongs to A in C. Definitely, there will be a function from A to C. There will be a function from A to C. The question is what name should be given to this function, newly formed function. To make a function from A to C, the condition should be the codomain of F should be equal to the domain of G. That means that center element is there, no. That should be common. The first condition to be followed is codomain of F. Codomain of F, that is equal to B. Codomain of F is equal to domain of G. Domain of function G. The first condition should be. This should be equal. That means this should be connected. This should be connected from to get a function from A to C. Okay, now right. What name should be given to this function? What name should be given to this function? Means the name is given as G circle F. Reverse order you have to give. Reverse order you have to give. The name of the function should be G circle F. Then how to function? We have to read it as G circle F. Golf. G circle F function is a new function which is from A to C. The domain is A and codomain is C. Understand this? Right. Then how to define? How to define? Let us see here. For example, I will show the notation. Your element is A, for example, A and B are two sets. If your element is X, your image is what you are writing? F of X you are writing. For example, if your element is 2, your image is 1. The element 2, its image is 1. Then 1 can be written as F of 2. That means 2 image is F of 2, that is given as 2. That is F of 2 is equal to 1. F of 2 is equal to 1. For element 2, its image is 1. Function name is what? F. Function name is what here? F. Your element is 2, image is 1. Here also, what is the function name? What is the function name here? G circle F. What is the function name? G circle F. What is your element here? X. What is your element? X. Now you are writing its image here. You are writing its image. What is the image of X here? G of F of X. This is the definition of the function, composite function. So now I will explain the composite function, clearly the definition. Let A, B, C be three non-empty sets. Let F from A to B is a function and G from B to C is also a function. G from B to C is also a function. Okay, now then there exists a function from A to C. There exists a function from A to C which is denoted as G circle F from A to C and defined as G circle F of X is equal to G of F of X. A very, very important point that you have to note down is for all X belongs to domain of F. For all X belongs to the domain of the function X. Okay, now, so this is the definition of the function G circle F of X. Okay, now let us see if it is another set is there D. If another set is also there D, then let us see what happens. Okay, now dear students, let us extend our knowledge of this composite function. Just we have seen 3 sets. If at all 4 sets are there, then what happens? Let us see that. Let us say that there are 4 non-empty sets A, B, C, D. A, B, C, D are 4 non-empty sets. Let F is a function from A to B, G is a function from B to C, H is a function from C to D. Let us say that there is a element in X, there is an element X belongs to A, under the function f, its image is f of x. Now already I told that G is a function from B to C. That means for every element of B, there exists a unique element which belongs to C. So what is the name of that element? G of f of x. Okay now? As already told that H is a function from C to D. Okay, so for every element of C, there exists a unique image in D. So what is its image is H of G of f of x. H of G of f of x. Okay now, so for every element A to A, for every element X belongs to A, there exists an image in D. Okay now, so let us see that first of all, from A to C, what is the name of this function? From A to C, I already told that you have to take in a reverse order, that is G circle F from A to C. See here in general day-to-day life, so if you want to come to from Delhi to from Delhi to whatever may be the city in Mysore. Otherwise you can you call it as a Delhi to Kanyakumari. You are to Kumari. So from Delhi to first you will get Bhopal, and Bhopal to you will get Chennai. From Chennai to Kanyakumari you will get. Can you get all trains? Sometimes you will get a train from Delhi to Bhopal, and Bhopal to Kanyakumari train you may get. Otherwise Delhi to Chennai and Chennai to Kanyakumari, directly Delhi to Chennai. Some interstate express will be there, direct to Delhi to you will get to Chennai, and Chennai to Kanyakumari local trains will be there. Understand this? So this is a process, means here I want to go from A to D. First I will go from A to C. That means Delhi to Chennai I went. What is that name of the train? G circle F. Understand? From Chennai to Kanyakumari. From Chennai to Kanyakumari. What is that express? H from C to D. H from C to D. Now what will be the function from A to D? What will be the function from A to D? As I already told you, reverse you have to take. Reverse you have to take. What is that reverse? H circle G circle F. H circle G circle F. Function name. This is from A to D. This is from A to D. Understand this? In another way also we can say. That is means, for example, I got a train from Delhi to Bhopal, and Bhopal to Kanyakumari I got the train. A reservation available. From that is, so this is from Delhi to Bhopal. What is the train name? F from A to B. Understand? Again Bhopal to Kanyakumari I got the train. What is the train? H circle G. H circle G is from B to D. H circle G is from B to D. Then what is the train from A to D in this case? So I already told a reverse process you have to take. That is H circle G circle F is also from A to D. Understand this? In both the cases, the name of the functions is only changed. So our ultimate goal is to move from Delhi to Kanyakumari. Our aim is to move. So, but different methods we got. Two methods we got. What is what? Delhi to Bhopal, Bhopal to Kanyakumari. Otherwise Delhi to Chennai, Chennai to Kanyakumari. Different way. Otherwise Delhi to Chennai, Chennai to Kanyakumari. That is the things we get here. Understand here. So these two functions are equal or not. These two functions are equal or not. As already we have seen in the equality of functions, two functions are said to be equal if and only if their domains and codomains are equal. Here domain is equal, codomain is equal. In whatever may be the method you follow, from Delhi to all will meet in Kanyakumari. Okay now? So therefore from this we can say this: H circle G circle F is equal to H circle F circle F. H circle F circle F. These two functions are always equal. But what about F circle G, G circle F? What about F circle G, G circle F? So if you see this, G circle F is a function from A to C. G circle F is a function from A to C, whereas F circle G is a function from C to A. F circle G is a function from C to A. Understand? Then in general, G circle F is not equal to F circle G in general. But sometimes they are equal. Sometimes they are equal. When it is means when A and C both are inverse functions of each other. Both are inverse functions of each other. Then F circle G will be equal to G circle F. So that I will tell afterwards. So this is the process of composite function. Understand this? So if it is like that, you can move any number of sets. Any number of sets we can move. Okay na? So I hope that you know what is the definition of this. In this case, what is the definition? Right? As I already told you, the function name is G circle H circle of F of X. This is equal to H of G of F of X. So this is the definition of the function H circle G circle F. Otherwise you can write it as a H circle G circle F of X is equal to H of G of F of X. H of G of F of X. H of G of F of X. That is the definition of the function. Okay, now let us move to some properties of composite functions. Okay, so let us start some very important properties of composite functions. Let us see the properties of composite functions. Okay, so here I am going to explain first two properties. The first property, see here clearly, F from A to B is a 1-1 function. What is the definition of 1-1 function? No two elements of domain should have the same image in codomain. That means one element, one image, just like in a bus. If there are 36 seats are there, 36 passengers should be there. That's all. Okay, compulsory. So of course, provided the bus is full, provided that means there is a chance of there will be an empty seats also. Okay, right. So here also the same thing. So clearly F from A to B is a 1-1 function. G from B to C is also a 1-1 function. One element, one image, one element, one image, one element, one image. Then is it not from A to C is a 1-1 function? Yes, clearly. What are the image of 1? X. What is the image of 2 in C? Y. What is the image of 3 in C? Z. That means if F from A to B is 1-1, G from B to C is 1-1, automatically G circle F from A to C is also a 1-1 function. But general proof is also there for this. General proof is also there. So it is very important for your board examinations. But I am giving just outline. Okay, right. For our objective point of view, I am explaining. Okay, right. Second one, see clearly F from A to B is an onto function. Onto function means what? Simply codomain is equal to range. Here codomain is what? 4, 5. What is range? 4, 5. So F from A to B is onto function. From G from B to C is also an onto function. Clearly A to C is also an onto function. Why? In place of C, the domain is equal to codomain. So from this, what is the second property? F from A to B is onto, G from B to C is also onto. Therefore, G circle F from A to C is also an onto function. Okay, so I hope that you understand these two properties. Let us see some more properties. Let us see the two more properties in the same diagram. Let F from A to B is a function from G from B to C, G is a function from B to C. Then it is a property is if G circle F from A to C is 1-1 function. See here, A to C is 1-1 function or not? Yes, it is a 1-1 function. Why? What is the image of 1? X. What is the image of 2? Y. What is the image of 3? Z. That means no two elements of A have the same image in C. Therefore, so if G circle F from A to C is 1-1 function, then F from A to B is also a 1-1 function. Must. F must be a 1-1 function. But try to understand this. It is a conditional statement. That means if F from A to B is 1-1 function, there is no need of that G circle F from A to C is 1-1 function. Try to understand. Here one more I will give one example. A, B, C. F is a function, here G circle F. This is G circle F from A to C. Okay now? Right. If F is a 1, 1 function, see here 1, 2, 3, X, Y, Z. F from A to B is a 1, 1 function. So here let us take that L, M. Try to understand this. From A to C is not 1, 1 function. A to C is not 1, 1 function. For what is the image of 1? L. What is the image of 2? L. That means two elements 1 and 2 have the same image L. So this is a conditional statement. Try to understand here. If G circle F from A to C is 1, 1 function, then F must be a 1, 1 function. If F is a 1, 1 function, there is no need that G circle F from A to C is 1, 1 function. Clear? Understand this? Right. Second one. If G circle F from A to C is onto function, clearly A to C is an onto function, then G must be from B to C is onto function. G must be an onto function. But it is no need that if G from B to C is onto function, there is no need from G circle F from A to C is onto function. Okay now? So there is no need that G circle F, if G is an onto function, from B to C is onto function, but G circle F from A to C may be onto function, may not be an onto function. Understand this? Right. So I hope that you understand this concept. Okay. So here I think if it is G from B to C is onto function, definitely G circle F is also from A to C is also onto function. Definitely it will be an onto function. Why? Because if there won't be any elements here. G from B to C is onto means G circle F from A to C is also onto. That I think this will be in the both the direction we can put. From G from B to C is onto function, then G circle F from A to C is also onto function. As we can put, but it is not, in reverse it is not possible. Here we can put it as from G from B to C is onto function. G circle F from A to C, already it is onto function. Onto function means what here? C. So domain is equal to, range is equal to codomain. That means here no element will be free. That means automatically A from A to C is onto function, right? Here both the directions we can take, but here only the single direction, okay? I hope that these properties you understand this. So let us see some more properties. Welcome to fifth property. If F from A to B is a function, then F circle IA is equal to IB circle F is equal to I. Then what is this IA, IB? Yes, already I told that IA means it is an identity function from A to A. IB means it is an identity function from B to B. A to A, B to B, identity function. A special notation, that's all, IA, IB. Okay now. Now let us see this how it's possible. F circle IA means, always remember that first if you want to write a notation, what the second one IA, no, you write that first one. So that means A. So this is a IA. Again F is a function from A to B. F is a function from A to B. Then what will be the function from A to B? Is it not the function from A to B? So this is a F from A to B. So what is the name of this function? F circle IA is also A to B. F circle IA is also from, always reverse order. F circle IA is also A to B. So both domains are equal, codomains are equal. Therefore F is equal to F circle IA. Then how to prove this? Second one, but general proofs are there, but it is not the general proofs. This is a one type of vague proofs, okay, just outlines. But for everything is a theorem. It is a theorem, okay. So you have the proofs, detailed proofs we have, okay. General elements you have to take. If your element is X, your image is IA of X. Again X. If your element is, your image is F of X. That means for every element X belongs to A, there is an image in F of X it be. That means X is equal to F of X. Okay. Therefore, F from A to B, just like general proofs also will be there, right? Now coming to how to prove this, IB circle F. So first here from this also I will put that from A to A. So this is IB. So this is a B to B. Okay, now from this here, you see here, from this IB circle F, IB circle F is from A to B. IB circle F is from A to B. Okay, right. So this is the, so both proofs are got. Now coming to there, if F from A to B is a bijection, clear here, A to B is a function, ordinary function, but here he is saying that F from A to B is a bijection. Why he is saying bijection? See here, F inverse is there. Already we explained that if F from A to B is bijection, then only its inverse exists. Okay, in the previous classes I explained this. Now see here, so there are three non-empty, here two sets are there. So here two sets are there. First you have to write down F inverse. F inverse means what? So F inverse is from B to A. So this is a B, A. So this is F inverse. Whenever you are writing, first you have to write down the second function, F inverse from B to A. Again, this is B, F. F is a function from A to B. Then what will be the new function from B to B? F circle F inverse. F circle F inverse is equal to, is it not B to B? B to B, then it is given as IB. Therefore, F circle F inverse from B to B is equal to IB. Then how to prove that? F inverse circle F. Okay, so for this what you have to take? Here also you have to take three non-empty set. First you have to take F. So this is F from A to B, from F. So F inverse is from B to A. This is F inverse. So this is F. So this is F inverse circle F is equal to, is it not A to A? A to A. So this is given by IA. So these are some of the important properties. F circle IA is equal to F, whereas F circle F inverse is equal to I. F circle F inverse is equal to IA. Okay, now so that is also the properties of this important property. So this will be useful while solving the problems. Okay, now so let us see some more properties. Let us see these properties of very important property. This is, so that is F from A to B and G from B to C both are bijections. Then obviously G circle F from A to C is also a bijection. So we can give number of examples here. So here A, B, C are three non-empty sets, F, G. So this is a G circle F from A to C. A to C is a function. Let us take the elements as 1, 2, 3 here, A, B, C here, X, Y, Z. 1 to A, 2 to B, 3 to C, A to X, B to Y, C to Z. Clearly, F from A to B is a bijection, both 1, 1 and on 2. G from B to C is also a bijection, that is both 1, 1 and on 2. Obviously, from G circle F, A to C is also a bijection. So, it is very clear. Now, then how to prove this? How to prove this? So, very easy thing here. This is a G circle F from A to C. G circle F is a function from A to C. Then what about G circle F whole inverse is a function from C to A? What is a function from C to A? Then how to prove this? How to prove this? Already I told that F from A to B, then F inverse is from B to A. Just notation. This is one notation. Another one is G is from B to C, then G inverse is from C to B. This is another notation. G inverse from C to B. See here, F inverse circle G inverse. First, what you have to take? G inverse you have to take. Okay. So, first G inverse. What is G inverse? CB. This is G inverse. Is a function from B to C, C to B. What is F inverse? This is F inverse. Okay, now what is F inverse? B to A. What is F inverse? B to A. Then there is a function from C to A. Then there is a function from C to A. What is the name of this function? Reverse order we have to take. That is F inverse circle G inverse is a function from C to A. C to A. So observe here, is it both are not equal? So this and this, both are not equal. Yes, both are equal. So that is G circle F is a function from C to A. F inverse circle G inverse also a function from C to A. Both domains and codomains are equal. So whenever G circle F whole inverse you got, that is F inverse circle G inverse, you can extend this. You can reverse way also you can write. Reverse way means what? F circle G whole inverse is equal to G inverse circle F inverse. Okay, now you can extend to number of functions also. You can extend this knowledge to number of functions. Okay, now so very important property this is, but general proof is there. So but general proof it takes a very long process. Okay, I am taking outlines. Okay, now let us see the last and final properties of this composite functions. In general, F circle G is not equal to G circle F. Already proved. This also F from A to B, from G from B to C, H from C to D. Then F circle G circle H is equal to F circle G circle F. Then when it will be possible, when it is F circle G is equal to G circle F, when it is possible, let us see that. Let f of x is a function e power x. Let f of x is a function e power x. Let g of x is a function log x to the base e. Log x to the base e. Let us find out f circle g, g circle f. So f circle g of x is equal to f of g of x. By definition, f of g of x means log x to the base e. F of log x to the base e is nothing but e to the power of log x to the base e, nothing but x. Okay, now right. Find out g circle f of x. This is g of f of x, that is g of f of x. F of x is equal to how much? E power x. What is g of e power x? Wherever x is there, substitute e power x. Wherever x is there, substitute e power x. So that is a log of e power x to the base e. That is x into log x to the base e. That is equal to x. So f circle g is equal to g circle f you got. F circle g is equal to g circle f you got. Understand? Right. If you observe, when it is possible, f circle g is equal to g circle f is possible means these two functions are inverse to each other. If these two functions are inverse to each other. So e power x inverse is log x to the base e. Log x to the base e inverse is e power x. Understand this? So in objective examinations also, for example, if f of x is equal to x square, if g of x is equal to root x, then you see here for both the things f circle g and g circle f, both you will get the same thing. Understand this? So if it is both are inverse, check whether it is you will get it or not. Just I orally I wrote. Okay, now right. For example, f of x is equal to 2x plus 3 and g of x is equal to x minus 3 by 2. F of x is equal to 2x plus 3 and g of x is equal to x minus 3 by 2. Then f circle g is equal to g circle f, obviously. Why? Because f of x inverse is g of x and g of x inverse is f of x. Here both domains are R to R. Okay, now right. So these are the properties of composite functions. So dear students, I hope that you enjoyed today's class. Okay, now in tomorrow's class, I will explain various number of problems which were given in the previous JEE mains examination or competitive examination problems based on these composite functions. Okay, now until then, all the best.